Go.
Recorded. Reference angles. This is it. Sighting. Pause this later. So number 1 is going to be 60 degrees. So because it's 120 degrees this way, what's left? There's the x-axis. There's the terminal side.
There's a 90, so that could be 30.
X-axis. X-axis, not Y. No, just the x-axis. So that makes this 60 degrees by definition, right? Number 2 should be 30 degrees. Number 3 should be, this is going to be scary, 45 degrees.
Wait.
Why is 2 210 degrees? So let's draw 210 degrees. 210 degrees, right? Right? So here's the x-axis. What's the angle between the x-axis and 210 degrees? 30. But first, who asked me this one?
Oh.
So this has to be 30 degrees, right?
Oh, right.
It's always x-axis to the terminal side. 210 minus 180 will give you 30. That's the difference between the two. We're always trying to get to the x-axis, whatever that might be, whatever it takes angle-wise to do that. That's what we want to do.
So what is 280?
280. 280 would be?
10?
80. Good. You guys are trying to think too hard. 280 degrees like this, right? 280 degrees. Agreed? Looks like that? So what you're saying, well, can I go? No, x-axis. X-axis. No y at all. Not talking y at all. It's 360 degrees. This is 280. That gap between them must be 80 degrees. Green, okay? Green, okay? Green, okay?
Wait, do we still have to write down the negatives?
Green, okay? Yes, okay. All right. All right, so why do we care for reference angles? Are you with me? Okay, so why do I care? This is why I care right here. Because as we're starting to do this thing, as we're trying to break something into components, which is our goal, we're going to look at this and we're going to go, okay, 230 degrees would be right here, right? What angle am I going to actually use?
40.
I'm going to use my 40.
No, wait.
30? Oh, no. What's my reference angle, everybody?
50.
50, thank you. So this is the x-axis, right? Here's 230. That's 180 degrees. So what angle am I going to use? 50 degrees. Agreed? So then I'm just going to do it just like we've been doing it all along, except I'm going to slap the negative on there if I need it. Okay? So break this into components. Go. I'm going to walk around and take a look-see because there's more confusion than I thought there would be.
I'm just confused on how it's 50.
Am I wrong? 230 degrees? Am I wrong?
No.
It's 230. So 180 degrees. So what's the gap between it?
Yeah.
Between the x-axis and 230 degrees. Yeah.
But there's no side.
I'm not going that way. I'm always going to the x-axis. That was our point.
Yeah,
Yep, then you have to switch it to sine and cosine.
something.
That needs to be x. I'll explain that in a moment. So, break components. Study.
Oh, this way.
Oh! That's why you guys are so confused. What am I missing?
A side.
How big is the side going to be? Parkhill.
I don't know. 10.
We'll make it 10. Make it 10. My apologies. I didn't have it down there. You got 10. No, you're not supposed to be choosing. I messed up.
I just no.
Now I understand the confusion. Break down components. Much easier when you actually have a side. It's okay to call me. Go, he's ready. I don't know what you know what you're doing.
I was like,
Don't do it. Right down the side. Look at that. Now, in the back of the room, over in the left-hand corner, there's Genius sitting right there. She just did something that I'm going to show you guys in a second, so I'll show it to you right now. Okay? And I should give credit before I did. Miss Cole, right? Miss Cole has got some genius going on here. She's tired of the triangle altogether. She has noticed the following bit of genius. She said, look, how many times to solve for the x side, what do we always do? We always use cosine, and we always multiply by the magnitude, right?
Yes, sir.
Isn't x always going to be magnitude, which, by the way, we're going to use r for, I apologize, r for cosine of 50 degrees. So she just went ahead and did x equals 10 cosine of 50 degrees. She's not even drawing the triangle. There's no triangle on her paper. She's trying to write 10 cosine of 50 degrees. Not even paying attention. Isn't that always going to be work?
Yes.
And then what's the y going to be? 10 sine of 50 degrees. Do you want proof that I came up with this before she did? In the middle of your paper on the back, it says, what is x equal to, what is y equal to? X equal to, y equal to? Make it r cosine theta and r, what's y equal to? R sine theta. Well, this should be theta. Sorry, my bad. Okay? Thank you, Miss Cole. Intuitive leap masterpiece back there. You still
They're
reading
both
now?
negative, correct?
Read this one. What are you doing?
oh, we just signed.
Just do the top one, and then we'll start talking about how fast we can go through these things.
Why would you use cosine?
Cosine is always going to be x. As long as you do the representative to the x-axis, it's always going to be cosine.
So why would we use sine?
Sine is going to be my y component.
Oh, it's if you were trying to find the reference.
You're trying to find my two components, right? So I whipped through this thing. Actually, let's let everybody get caught up, and then let me show you.
Actually, it's one very hard.
Oh, here's our cosine. Look at this back here. Woo! Oh man, gotta fix that worksheet. All right. Here we go. Here we go. So x is gonna. So how am I gonna write my components? 10 cosine of 50. 6.4 I hat plus 10 sine of 60. 8.7 j hats.
Wait.
Ah! What did you wrong? 10, so I did sine 60. My bad. I did both wrong, didn't I? Did I do the first one wrong?
No.
Well, that's weird.
But it's
How did I get the
negative.
second one right? Oh, yeah. Yeah, I've done that yet. I was going to fix that in a moment. Okay, so let me get this part straightened out, and then you guys get to make fun of me. Is that right?
No.
No, why isn't that right?
It's not negative.
Third quadrant, right? I know I'm in third quadrant. Both of these going to be what?
Negative.
Negative. All right. You've got 4 problems to do there. Do not go past those 4 problems. If you go past the 4 problems, I get to make fun of you for hours.
What is the x?
Hours. Not days, not months, just hours, but more than minutes. Do the next 4 problems. Go. Once you hit the joy of calculus, and once you hit the brakes, go, oh, slow my roll.
What are the x and y there for?
That's where you write down these 2 things. I said, make sure you write these things down because Cole jumped the gun and said, this is the answer. I said, well, Cole's got it. We should share it with the rest of the class. She's just cheating back there all by herself. How long have you been doing it the wrong way? Good job. You know, I certainly expect your other 2 teacher probably brought this up because your other 2 teachers very into x is equal to and y is equal to. That's when he teaches trig, man, those kids know x is equal to, y equal to, like nobody's business. I can't even think x and y equal to anything else. Crazy thought. It's the same thing. Yeah, good. Then you can jump right to it. Because that's my son. What you see, it's the same thing.
Would it be there?
That's what you got.
You're gonna watch your minus signs though, right? One. Singular notation. Every step of the way. One. Singular notation. Every step of the way. 190 degrees. So I'm going to go 10 degrees reference angle. X equals R. Cosine of 10 degrees. Y equals R. Whoops. R sine of 10 degrees. 15 minutes left. Woof. Running against it. 22.7 I hat. For J hat, negative, negative, boom. And then number 2, same exact reference angle, different quadrant, so it's going to be negative 22.7 I hat plus 4 J hat. How are we doing? Keep working, keep working. I need to get to the bottom of this worksheet and start the next one, otherwise we'll be trouble. Trouble, trouble, trouble. Trouble, trouble, trouble. Chatting about nails, get the work done. I'm kidding.
You're just singing Taylor Swift back there.
Was I?
Yeah.
Is that Taylor Swift?
Yeah.
That's cool. She sang a better song than I thought she did. I was stereotyping her. I don't know who she is. That's probably why. Oh, good Lord, that got recorded. You should be able to go, this thing is 60 at 0 degrees. Agreed? This is 50 at 60 degrees. Agreed? That means that this thing here is going to be, x is going to be what? R cosine theta, so it's going to be 60 cosine of what angle? 0 degrees. And the y is going to be what? 60 sine of 0 degrees. So I put that in my calculator. And I get 60 I hat plus 0 j hat. And then I look back a little sheepishly because, right, it was 0 degrees, right? So that goes 60 to the right and 0 up. Oops, I should have been able to do that without a calculator. That's okay, we're in calculator land. Let's do the second one. The second one's going to be, x is going to be 50 cosine of 60 degrees. And y is going to be 50 sine of 60 degrees. Agreed? Just like doing that, I think. So we get with 25 I hat plus 43.3 j hat. Now I'm going to add my components. 85 I hats plus 43.3 j hats. Now I have my instructions. What do I do with my instruction, Miss Green? Now I got my instructions. I added up my components. So what am I going to do with my instructions? Has to be louder. Okay, look at this. The sheet. I gave you a hint on the sheet. And here's the answer. Smirk at me. This is the answer right here, down here. Answer, answer, answer. You know, it's really cool. When it's recorded, for whatever reason, it has a little like halo that follows my pen around. Like when I'm writing, it's really weird. I'm not sure how it does to do that. Hey, Matt. Pause.